Hi, my name is Mel, and the following presentation will provide an overview of VPNs covering their core concepts, operational mechanisms, security features, and practical setup to set up VPNs for remote access. We'll explore theoretical foundations and hands-on guidance to enable secure and effective VPN usage. Because you can use VPNs in a lot of ways. So if you're just an individual person, you can set up like WinScribe or OpenVPN to secure your own personal internet connection and mask your internet address. All right, so that could be a really good idea if you're doing financial or banking, anything over the internet, or if you don't want every person and their dog spying on connection, which it's a very good idea to set up a VPN in all cases, I would say. You can also set up like a VPN going into, say, like a database server for remote workers and stuff like that. You'd obviously set up firewalls, but that's a lot of ways you can use VPNs. So this is just sort of covering the basics. We will begin by introducing VPN basics and terminology, examine how VPNs function. Then we will discuss encryption and security practices followed by practical setup instructions for remote access. Additional topics include detailed VPN tunneling, home setup guides, remote database access demonstrations, and advanced management features. The following section introduces what a VPN is, its main purposes, common use cases, and essential terminology such as tunneling, encryption, and protocols to help build foundational understanding for the rest of the presentation. A VPN or virtual private network creates a secure connection over a public network, allowing users to access resources privately and safely. Its primary purpose is to protect data privacy and enable secure communication across untrusted networks. And certainly, yeah, that's what I'm saying. I would use VPN when you can. It can be slow though, but yeah, I would use VPN. VPNs are widely used for remote work access, protecting online privacy, bypassing geographic restrictions, and securely connecting branch offices. Understanding these applications highlight the practical value of VPN technology. Key VPN concepts include tunneling, which encapsulates, which is sort of like encapsulates, like you've got a data packet and then you've got this data packets. Encryption is just like using algorithms to mask your data, so it changes what's there from plain text to encrypted. So you have encryption, different types of encryption standards. We'll talk about this in another video, which secures data, and protocols which define how VPN's connections operate. Familiarity with these terms is crucial for grasping VPN technology. Yep. The following section details the technical workings of VPNs, including their architecture, data encapsulation techniques, and the main protocols to establish and maintain secure VPN connections. VPN architecture typically involves clients initiating connections, servers managing access, and secure endpoints where data is decrypted. Understanding this structure clarifies the data flow within a VPN. Encapsulation wraps data inside VPN packets for secure transmission, while tunneling creates the virtual pathway for these packets across public networks, ensuring confidentiality and integrity. Common VPN protocols vary in security and performance. PPTP and L2TP are older. OpenVPN and IPsec are widely used for strong security. I think I have set up OpenVPN and IPsec. I don't think the other two older ones are used much these days. WireGuard is another one, modern efficient protocol. Yeah, IPsec widely used, WireGuard, OpenVPN. I don't think PPTP and L2TP are used very much. They are for, you know, they're simple and they're much faster too. WireGuard is more modern too, so they're used as very much as well. VPNs rely on robust encryption and authentication to secure data. This following section examines how encryption protects data packets, the methods used for authentication, and strategies to mitigate potential vulnerabilities. And VPNs can be very vulnerable too, so that's something that you should think about. There are mitigation things and strategies you can use to help prevent that. VPNs use encryption algorithms like AES to convert data into unreadable formats during transmission, ensuring that intercepted data remains confidential and secure from unauthorized access. Yeah, I've had AES, I think 256, 5112, I've seen too, 128 you could, but I wouldn't use 128, 256. I think 5112 is sort of what's now there. I've set up 256 and 5112, I'm pretty sure. So yeah, I wouldn't use the 128. You can also use hashing and salting, and we'll talk about encryption in another video, but yeah. VPN authentication methods include username, password, certificates, and multi-factor authentication. Best practices involve regularly updating credentials, using strong encryption, and applying strict access controls. Potential rules include DNS leaks, weak protocols, and endpoint security flaws. Mitigations involve using updated protocols, leak protection techniques, and secure endpoint configurations to maintain VPN integrity. And we'll cover DNS leaks and other things like that that can be problems. You know, cross-site scripting, it's not necessarily a VPN issue, but like DNS leaks might be man in the middle, like also other things that could be problems. We'll cover that in another video. The following section guides through assessing needs, selecting VPN solutions, configuring servers for secure access, and managing remote client connections to enable safe and efficient access to databases or networks. Because it might not just need a database, it might need to use anything on the server or networks. They might need to use anything on the networks. Okay, we're going to cover databases in another video as well. Evaluate security needs. Use user scale, compatibility, and budget. That's the big one, budget, to choose the appropriate VPN type, whether commercial, open source, or enterprise grade, tailored for remote access requirements. And look, you need to also talk to the users in a company to find out what they can use and what's going to be easiest to set up for them. And also, you've got to look, budget's going to be a big one for any company or any person that you're looking to help with this sort of stuff, because obviously what they can afford is going to be what goes there. There are some free limited versions, but they are quite limited, but you can use like Windscribe for free, OpenVPN I think is free for a certain amount, but they do, there are limitations to how much you can use your data usage on those. But there are like definitely different solutions you can look at here, okay? Server configuration involves setting encryption standards, access permissions, and user authentication methods, and firewall adjustments to securely manage incoming VPN connections. And yes, you certainly need to do all of those, all right? Because you would not have you'd have to have a firewall between the VPN and any sort of server as well, because you just ask, even though VPNs are encrypted, and if you tunnel or use IPsec or, you know, like WireGuard or any of those, you still would have a firewall at all cases, all right? You just have to. Remote clients must be properly authenticated using secure credentials or certificates with access controls enforced to restrict resource availability based on user roles and policies. Yes. The following section explores the tunneling process in depth, including how data is encapsulated, the difference between transport and tunnel modes in IPsec, and the concept of split versus tunneling. Tunneling wraps original data packets inside new packets with additional headers so they can securely traverse public networks, effectively creating a private communication channel. Okay, so that's what tunneling means. All right, you are going through a public network to create a private communication channel. You can have dedicated private networks too, but that's sort of not what we're covering right now. In transport mode, only the payload is encrypted, while in tunnel mode, the entire packet is encapsulated and encrypted, providing different security levels and use cases. Split tunneling allows users to access VPN and local networks simultaneously, improving efficiency but with some risks, while full tunneling routes all traffic through the VPN for maximum security. Learn how to select suitable hardware and software, configure your home router to support VPN connections, and test your setup for reliable and secure remote access. Choose VPN-compatible routers or dedicated server and software that meets your security and usability needs, considering factors like protocol support and ease of configuration. Look, honestly, most routers, if you're just a lone person, your routers, your modems, or whatever you've got your at home should be compatible with most VPN. It really should. If not, you need to talk to the internet, ISP provider. Because you need to really get them to give you a modem that's going to be able to do that. But most should, seriously, unless they're legacy. But look, you really need to talk to your ISP with that if that's going to be an issue. Set up your router by enabling VPN server features, updating firmware and configuring network settings to allow secure VPN connections into your home network. Usually, look, from your home computer, you can usually set up VPN, like with Microsoft Windows, you can set up VPN, other things, you can just do that, and it should just set it up all for you. If not, you can use stuff like Copilot or Google, anything like that, Bing, to get instructions. But I would also talk to your ISP, because you do not want to be fiddling around with your router or modem settings if you don't know what you're doing, because you might really stuff something up. So talk to them, because they might actually be able to do that for you. Verify VPN and connectivity from remote devices. Troubleshoot common issues like blocked ports or incorrect credentials, and secure, stable, and secure access. The following section provides practical steps for configuring firewalls, establishing secure client-server communication, and applying best practices to maintain database security via VPN. Proper firewall and NAT, which is network address tables, configurations are essentials to allow VPN traffic while blocking unauthorized access, enabling secure remote database connectivity. Implement encrypted tunnels and strong authentication to ensure that data exchange between remote clients and the database server remains confidential and intact. Use least privilege access, regular updates, and network segmentation and monitoring to safeguard your database when accessing remotely over VPN connections. Explore how to monitor VPN activity, scale infrastructure for numerous users, and integrate VPN solutions with cloud services and hybrid network environments. Effectively monitoring and logging help detect security incidents, analyse usage patterns, and ensure compliance with organisational policies. And also too, and helps for any auditing or governmental compliance as well. If you need to do digital forensics or sort of look at what's going on in your system, logging and monitoring, you can get a lot of tools, or we cover tools that you can log and monitor in your systems, to like cybersecurity tools and others that you can use here. Honestly, you need to be in compliance with governmental regulations of whatever country you're in. Techniques for scaling include load balancing, deploying additional servers, and optimizing configurations to maintain performance and security as numbers grow. Integrating VPN with cloud platforms and hybrid environments enables seamless, secure connectivity across diverse infrastructure setups, supporting modern enterprise needs. So in conclusion, VPNs are vital tools for securing remote access, combining complex technology with practical applications, understanding the function, security aspects, and setup procedures empowers users and organisations to maintain privacy and connectivity. Yep. Thank you for your time.